The computer industry is going through some really dramatic changes, and one of the reasons for that is the discovery of a new form of machine learning called deep learning. And deep learning is almost magic. It's software that writes software by itself. It's computers that's learning by itself, and it's magical because you could give it a whole bunch of examples, and you don't even have to. That wasn't me. That wasn't me.
Change the mic.
Thank you. I'm doing everything to cooperate. I'm good? We settled down now? And so it's amazing because the software, if you give it a lot of examples, it will actually find out by itself what's important. It'll figure out what's important, the important features. There's this feature detector that's based out of convolutional neural networks. And because it has so many different layers, it could start from very low-level features and build up more and more and more abstract, higher-level features until eventually, from pixels, it determines it's a cat. From pixels, ones and zeros, it determines it's a cat. And it has so much dimensionality, it has so much detail in its neural network, it can actually detect which species of cats. And yet, it's not so easy to fool because it's generalized. So if you change the color of the cat by giving it hair color, turn it blue, it would still know that it's a cat. And so it's an amazing thing. It's an amazing thing. On the one hand, it's very dimensionalized, so it can recognize a lot of very subtle details. On the other hand, it's very hard to fool. It's generalized knowledge. And this neural network was first applied to, of course, computer vision, but it was applied to a whole bunch of other stuff. And so almost any situation where you could have information, data that's very messy, and you don't know how to write a piece of software to figure out how to analyze that data. You could use many, many examples of data like it, and you can train a network to automatically determine the features and automatically determine, based on all this data, how to predict the future. How to classify, how to recognize, how to predict, how to recommend. All of these type of machine learning capabilities, artificial intelligence capabilities, what we consider to be intelligence, are now being explored using this approach called deep learning. Simultaneously, at the same time, the computer industry, as you know, people have said the end of Moore's law. But basically, the combination of transistor performance no longer increasing without dramatic increase in power, simultaneously with the fact that we just simply don't know any more good CPU architecture techniques. Those two combination has reduced the performance roadmap of CPUs. And so you can see the progress of CPUs has really slowed. On the one hand, you've got this amazing new computer algorithm approach called deep learning that needs an enormous amount of computation. On the other hand, we just simply don't have enough computation to offer. And that opportunity and problem is essentially what created all of the excitement around GPU accelerated computing that we pioneered. The approach that we pioneered is a parallel processor that is able to intercept, offload the key kernels of a program so that we can accelerate it beyond reason. And in fact, if you take a look at many of the interesting algorithms that we process, that we accelerate, the speed up of the applications could be 10, 50 times. 50 times. The way to think about 50 times is if Moore's law was continuing, every 5 years you would get five times. Every 5 years is 5 times. Every 10 years is 25 times. Okay, so 50 times speed up essentially gave you somewhere along the lines of a decade and a half. That's why people call it a time machine. We can solve problems that would have taken us another decade to solve, and we brought it into the present. Or another way to think about it, because we're able to see the solutions that otherwise would have taken a decade to have happened, we are seeing the future, a time machine. And so the GPU accelerating approach that we pioneered over a decade ago has now reached a tipping point, and everybody's jumping on it to help solve otherwise previously believed to be unsolvable problems. And these unsolvable problems are happening everywhere. They're happening in transportation, they're happening in healthcare, they're happening in finance, they're happening in enterprise, they're just happening everywhere. They're happening in farming, they're happening in retail, it's happening in, of course, internet services and consumer applications. It's also happening in toys. Even toys are able to recognize kids' voices and do funny and magical things. And so we're starting to see that what historically would have been believed to be unsolvable problems are now being solved with this new approach. And that's the exciting part for Israel. This is Startup Nation. This is Startup Nation. And what startups love is great discontinuities. What startups hate is status quo. What startups love is when things change, and things change dramatically. And we have not seen a dramatic change in the computer industry. We have not seen a dramatic change in consumer electronics. We have not seen a dramatic change in industrial technology, enterprise technology. We have not seen dramatic changes like this before. And that's why the excitement all over the world. There's a lot of really exciting AI startups here in Israel. And that's one of the reasons why I'm here. What NVIDIA is about is we're about building this computing platform, which is basically a tool. We're about building a tool for researchers. We're about building a tool for developers. We're about building a tool for people who are trying to create tomorrow. These guys, you know, these people that are starting these startups, these founders, these entrepreneurs, they're looking for that incredible new tool that they could apply to solving problems that otherwise would not have been solvable before. Otherwise, what's their opportunity? And so the timing is just incredible here for Israel. And all these startups recognize that. And so we're here to support them, let them know that we're here to support them, to create a platform that they can all access, and wherever we can, wherever I'm able, to give them an opportunity to have a global voice, so that they can be as successful as fast as possible. And I'm also here so that we could collaborate with them. Many of them are doing things that are super important for our industry, and super important to me, and we could collaborate with them. Okay, so those are. Let's see. I talked about why the big deal happening in the industry today, and what does it mean to Israel? What's the opportunity for Israel and in Startup Nation? And then during the keynote, I talked about three things. I talked about a platform that we created called Holodeck, so that we can go into this virtual reality world to create things that otherwise would have been too hard to create. Imagine in the future we're going to create these little micro machines, little tiny micro machines, and they otherwise would have been very hard to create. But if you're in virtual reality, you can make it as big as you want and interact with it. And maybe the things we want to create are such large scale that it's hard to imagine doing prototyping in physical space. You could do it in virtual reality. Maybe it requires engineers from so many different disciplines, and they don't all sit in the same office, but we want to virtually collaborate. And so I can invite my friends into my lab, and they'll be standing in front of me just like this. But we're completely in separate places. We're completely in separate places. And so this virtual reality laboratory that on the one hand could be so realistic that we can actually do real things inside. It's, on the other hand, a virtual world, and so we could do superhuman things. I also talked about our AI platform. AI platform that is powerful, accessible, productive to use, that every deep learning researcher can use in the world. And after they're done developing their network, they could use our new platform called TensorRT that does the optimization and tuning, and so that the performance of the network could be very, very fast. And you guys saw the speed up of 100 times from before TensorRT versus after. Okay, and so that 100 times speed up translates to 100 times lower cost. All of their service, all the money that they would have spent letting people run the services, running the services in the cloud will be reduced by 100 times. Okay, so instead of a penny per customer transaction, now it's 1/100th of a penny per customer transaction. Now, of course, it sounds very, very cheap, but when it multiplied by 1 billion, that's a big number. And so many of these startups, when they put it in the cloud, they're so excited because on the first day, it's available instantly. And then as the service starts to grow, that joy turns to fear, and because the money's starting to crank up. And so now we create this platform that makes it possible for them to reduce the costs tremendously. Our platform is available from every cloud in the world, so they could operate their service from every cloud in the world. And then I also talked about autonomous machines. The first example of an autonomous machine, self-driving car. But that won't be the last. That's just the first one. And the reason why we're working on the first one first is because it has dramatic impact on society. And quite frankly, it's the easiest one to do. And the reason for that is you just have to teach the car not to hit anything. In the future, we have to teach these robots how to interact with everything. Hit that. That's called a collision. That's another collision. And so we have to teach all of our autonomous machines how to collide, and collide in a way that is helpful. Okay, how to collaborate with me. Imagine I've got this virtual robot, and it's inside holodeck, and I'm in my lab, and my lab has this incredible holographic display in virtual reality, and I'm designing all these things, and I say to my robot, I said, Isaac, hand me that screwdriver. Isaac will just hand me the screwdriver. Okay, in virtual reality. And then if Isaac doesn't do a good job, I said, Isaac, here, let me show you how to do that. And Isaac will continue to learn. And someday, we'll take the whole Isaac brain and move it into reality. We put it into a robot, and the robot knows exactly what to do. Okay? And so that's what holodeck is about, that's what Isaac is about, and we created this processor, this brand new processor called Xavier that's intended for just that purpose. That's it. That's what I talked about. Yes, sir.
I have a question. Although we are in, Daniel from HT Magazine, although we are in an AI event, I would like to ask about if it's possible with you about the consumer market. Since NVIDIA is known for most computer users for their GPU cards, what's the next, for example, right now we have 1080, 1070, 1050 cards. What's the next in the consumer area?
The next one will surely have numbers larger than 1080. That's this trend. I feel that we need to break that trend, but I hope it's not 1190 or something like that. Oh no, I just tainted that word. I might have to use it. I have no idea. Well, next year will come soon.
Okay.
Next year will come soon enough.
So
I'm super excited. Here's
so what's the scope for next year in terms of NVIDIA?
Well, next
what's
year,
the news?
I'm going to save next year for next year. Let's talk about this year. And the reason, look, NVIDIA has such large scale. The way to think about that is, no computer graphics company in the history of computer graphics has ever had this scale before. We dedicate more in R&D per generation than any computer graphics company in the history of the world. And each generation is like $2-4 billion. $billion. And it comes out, and it's a GPU. I had one in my pocket earlier. And so it's a GPU. It's the most complex processor in the world. And our goal is to recreate virtual reality and suspend you in that disbelief. And we have so much to do, from all the physics simulation in the world, and then the rendering of the beautiful graphics, and the lighting has got to be great, the material reflections has to be great, and the shadows has to be beautiful. All of your clothes, my leather jacket, it wouldn't look the same if the shadows and the light and the self-casting of shadows isn't just perfect. And so all of that has to be done wonderfully. And we want to create, these shared virtual reality worlds. So there's so much to do.
Thank you.
You said that you are here because we are a startup nation. By the way, sorry. I'm Sol from Tape Out Magazine and Chip Portal.
You have a magazine called Tape Out?
Yes. Tape-out magazine.
Is it a chip
Dedicated
tape
to,
out?
yes, semiconductor.
Fantastic.
Yes,
Wow.
yes,
That's
in
a great
Hebrew.
name. Yeah, tape out magazine. Okay.
So,
We're taping out Xavier right now.
great. So we'll be happy to write about it. You know, all the major players in the industry, starting from Google, Amazon, Facebook, Intel, Samsung, Apple, they are all here big time developing products. NVIDIA, up to now, we're not very specific in Israel. Are you going to expand your operation, your development center here?
Yeah, first of all, I appreciate the question. All of the companies that you mentioned are giant companies.
Okay,
They're giant companies. Compared to all of them, we're a tiny little company, as you know.
okay,
And so, and we are. And NVIDIA only has 12,000 employees worldwide. And the vast majority of our employees are in Silicon Valley. And we're a startup. And we're a startup. And so we're you know, our journey into a global large company is just starting. It's just starting. And you mentioned some really great companies. And the reason why they're here is the same reason why I'm here. They're just extraordinary talent. And this is a great culture for innovation. And for all the reasons of your education, the military system, the culture of the people, the diversity of cultures and ideas that has created Israel, may very well have created this flashpoint of magic that other companies have noticed and that I have noticed. And so I'm excited. I'm excited about our future prospects here in Israel.
you're going to increase the number of developers here?
Yeah, we have 20 people today, and we just started. Per capita, there are more engineers per capita in Israel than any other place on earth. And even the people who aren't engineers know a lot about the technology companies. Surprising. You could have a perfectly entertaining, high-tech conversation with my waiter for lunch yesterday. You know, he knows a lot about a lot of things. And so they track the stock, they track all the startups, and it's amazing. It's amazing. There's a passion for technology and entrepreneurial spirit here in Israel we want to tap into. And so I want to grow here. The most important thing for growth, the only way to sustain growth, is one, you need to have the determination to want to be successful in that country. And one, we do. And then you can only be determined and want to be successful in that country if it turns out that country has a natural reason for you to be successful there. And the natural reason for us is there are more GPU developers here per capita, NVIDIA GPU developers here per capita than anywhere in the world. I think Silicon Valley is probably the only other place. There's so many people here trying to solve the unsolvable problems in the past. There's so many people here who want to create the next great thing. They need to use the next great tool, and NVIDIA's GPU is really the next great tool. And so we have a lot of great developers here. I heard something along the lines of 400,000 developers here, software developers here. That's a lot.
Right.
You know, that's a fair. You think that's too many?
I don't know. I thought you finished.
That's a lot. There's 7 million people in Israel, right?
Eight.
8.5 million. Okay, so let's say 8.5 million. 8.5 million. 8.5 million. 400,000 is a large percentage of that.
Right.
Unbelievable.
True. But
You know,
there's
almost
also an
everybody knows how to
ecosystem.
program software. I bet. Yeah, the waiter probably was incredible.
No, I'm saying there's an ecosystem. So you can benefit from the fact that all these guys, you know, Amazon and others are doing artificial intelligence, machine learning. You can also get the talents
Yeah.
to NVIDIA.
Yeah.
And you
No,
cannot
you're right.
get it everywhere in the world.
You're right. You're absolutely right. That's why I'm here. That's why I'm here. And so our journey just started. We're the smallest of all the companies you mentioned, and it's nice to be mentioned in that same sentence. But our journey is just starting. Yes, sir.
How important is Jacob Zalel Auto News? How important for you is the automotive industry in your journey to become a big company? How do you see this industry, which is very traditional industry? How your relationships evolving?
Mhm. You guys heard the question that has to do with the automotive industry and our journey. We've been in the automotive industry now for 10 years. And we started out in infotainment. And our primary focus now is artificial intelligence and autonomous driving. And then recently, we're going to go reshape infotainment by turning infotainment into an artificial intelligent agent. So your car will be hopefully rather intelligent and just a step ahead of you, so that make your transportation experience as nice as possible. And I think the first thing to learn about the automotive industry is that there's a reason why it moves slow. There's a reason why it's cautious. And it's cautious because the impact to society is great. It's a good reason to take your time to meticulously engineer a great product. On the other hand, technology is changing incredibly fast. And if you take too long, you don't benefit from the groundbreaking revolutionary technology that would have made the car way safer than good engineering. Sometimes great inventions will completely overwhelm all of the hard work and meticulous work of great craftsmanship. Okay? And so artificial intelligence surely has that capability. And getting that technology into cars as quickly as possible is going to be a benefit. And so the automotive industry is confronted with these two tensions. On the one hand, engineering something that is of great craftsmanship and great craft and great quality, great safety. On the other hand, that has the latest generation revolutionary technology that allows them to do something that traditional automobiles cannot, autonomous driving. And so these two tensions are there. We just simply have to, like we do with everything else, respect the ecosystem. First of all, if you want to change, and you want to increase the velocity of your partners, the first thing you have to understand is why can't they go faster? And to be empathetic to the challenges that they have. And I think we have. The fact of the matter is, autonomous vehicles are going to reach the road faster than anybody expected. If you remember the original timeline, it was 2025, 2030.
What's your timeline now?
You're going to get level 5 taxis, robot taxis, in 2020 for sure. 2019, you're going to get a lot of pilots. 2020, you're going to get a lot of commercial production robot taxi services. And then 2021 and 2022, you're going to see level 4 autonomous vehicles on the road.
What will be your share of the hardware which will go into robotaxi?
The question is, what do I think our share is? I think our share
Your
will
market
be
share, yeah.
I think our market share will be very high. The reason for that is because there aren't that many companies who are focused on level 4 and level 5 cars. That's where our company's focus. We're focused much more on autonomous vehicles, and we've dedicated almost 10 years to solving this problem. And so I think we're making great progress now. But it's such a large industry. There's trucks, there's cars, there's shuttles, there's all kinds of stuff that's being built. And everything that moves will be autonomous someday. Everything that moves will be autonomous someday. Not because it will be completely driverless, but the autonomy assists and augments the pilot or the operator. It could be a farming equipment, it could be, right? There's all kinds of things that are going to benefit from autonomous capability. And so I think the market is just really, really large. It's too early to worry about share, to be honest. The first thing that we have to do is just really focus on getting the technology done well. Make sure that the performance is good, the safety level is good, and help some of our partners get onto the road.
Actually, you are a competitor to Mobileye and Intel.
Uh-huh.
How do you see this competition?
Well, first of all, Mobileye is incredibly successful, as you know.
Yeah,
Right.
they were sold for 15 million pounds, so they're certainly successful. But is their technology is really that good?
Is Intel's technology really that good?
Yeah,
Is
but
that the
is
question?
Mobileye's technology is really?
Well, Mobileye has excellent ADAS technology. We got to give them that.
Okay.
They really invented modern ADAS, and autonomous vehicles, of course, is ADAS plus a bunch of other stuff. And I think I fully expect Mobileye to be a great competitor there. And as you know, Intel has excellent technology. You know, Intel is a formidable company, and when they set their sights on something, they tend to do a very good job. And so I think for us, this is an area that we have a lot of capability, and we have a lot of unique capability. And I think that our focus and dedication on creating an open platform on the one hand, but there's a fully drivable stack on the other hand, gave us the expertise of creating the entire stack like nobody has today. And so I think we're in quite a unique position, but the whole world is going to benefit from all of us trying to solve this problem. Yes.
Mr. Huang, thanks for coming to Israel. My name is Eli Kaplan from Cars Forum,
Hi.
and this is Israel's largest modern community. So one of the questions we're already taking pictures up in front of me. The other one that I had is, I noticed you mentioned in your keynote both Drive IX as a technology to kind of enhance and augment the driver's capabilities, and on the other hand, Drive IV, which basically renders the driver unimportant anymore. Or
Yeah.
how do those coexist?
Yeah, Drive AV is an autonomous driving stack and autonomous driving capability. And there are places that the car just simply won't be able to drive autonomously yet.
Where do you expect those to be?
It could be in a whole bunch of places. I mean, maybe because we want to be conservative, so long as soon as if the weather condition isn't very good, if it's snowing, of course, if it's raining harder than we like, we might use the weather system, the weather information on the internet to prevent you from going into autonomous driving mode. And so the combination of the HD map, the perception capability of the car, the weather conditions and the dynamic reports that we all have access to, the combination of all that might inform us that autonomous capability, autopilot, will not turn on. During that time, I would still like the AI to still be functional. I would still like, even though I'm not driving for you, I'm going to watch out for you. Does that make sense? Even though I'm not driving for you, I'm going to watch out for you. And so you're responsible for driving, but I'm going to be an extra pair of 94 eyes, okay? That watches everything around you just to make sure that you're as safe as possible. Now, once your car is an AI, it can see outside, it can see inside. It knows where my eyes are looking. It knows, traffic's coming from this side, but my head's pointing over there. It knows what my passengers are doing. Maybe the cabin is too noisy, people are laughing, but I want to turn down the radio because everybody's having such a good time conversing, but it can't hear me. However, if it reads my lips, it says turn down the radio. Oh yeah, I can still see it turn down the radio. Okay, there are all kinds of things that you could do that's fairly magical if you had AI. And so we're going to turn the whole car into an AI.
But then you would need to kind of form more bonds those technologies already exist today, like at least partially.
Yeah, partially.
What are the challenges you see around working with OEM with the automotive industry? Some of them have been answered before. But again, you mentioned like it's being slow to adapt those changes.
No, I would say the automotive industry actually works really hard and really fast. It's just that every car is different. They don't have the benefit of standardization. When you don't standardize, when every single car is different and every single platform is different, the rate of the velocity of development just tends to be slower, right? Because you need to do 14 things for 20 companies instead of one thing for 20 companies, and so there's just a little bit more inefficiency that comes from the fact that every car is a little different. Everybody's pace is a little different. Everybody's architecture is different. And so it's just a large, complicated industry. But you know what? We're just going to have to work through it. I mean, this technology is so important. We're just going to have to work through it.
One tiny question, if I
ahead.
may, another
Yeah.
one on a different angle.
Yeah.
So one of the things that NVIDIA did was taking the general purpose CPU and create an accelerator which is domain specific, which is the GPU.
Yeah, right.
And if you kind of look at the market, you can see companies like Google going even to the more extreme, offering the TPUs, which do very
Application specific.
application
It's not even
specific
domain
job,
specific, it's
which is
application
kind of more energy efficient
Yeah.
and supposedly more performant.
specific. Right.
Do you think you'll be going down this path as well?
I don't think so. I think there's a benefit for application specific. Application specific, of course, gives you the chance, the opportunity to optimize for one thing only without compromise to anything else. Okay, so that's obviously the benefit. This benefit, or the benefit of domain specific, is that because my market reach is relatively large, that every year we could sell $10 billion worth of GPUs, it affords us a $3 billion R&D. Now within $3 billion, the craft, the meticulous craft that we can engineer into one of our processors is so extraordinary that it actually overwhelms application specific with a small team. We use a massive engineering capability with extraordinary, we can invest in a way nobody else can. So our scale allows us to overcome the benefits of specificity. Our scale allows us to reduce our cost. Our scale allows us to undertake extraordinary challenges. Does that make sense? And so long as we're domain specific, if we're completely general purpose, then what I just said is nonsense. But if we're domain specific, we're within the same category, we have a much larger R&D capacity as a result.
Thank you.
Yes, sir.
Alex with Hardware Addicts.
Hi, Alex.
This is the second time I've seen your keynote. I watched your one in Munich. The whole idea of the holodeck and AI, would that possibly be used for gaming? Like, would we be able to go into the holodeck and have a game with our friends all around the world? I mean, is that a possibility?
Yeah. Everybody heard the question. The answer is absolutely yes. In fact, most of the time when people are inside the holodeck, even though they're just working, they're laughing. It's hilarious. It's hilarious because here, look, somebody go, hey, look, they pick up the card and they shrunk it into a little tiny model, holding their hand. I think that's funny. You know, it's incredibly funny. And so we took that same environment and we created this thing called a fun house, a virtual reality fun house. And it based the laws of physics. And so you go up with your remote and you brush on this little sponge head, and you could feel it, and it's moving like spring. And that's incredibly delightful. The idea, just little things like that, squirting water at each other, because water obeys the laws of physics. Chasing down balloons.
And you would feel the water.
Yeah. Yes, it's kind of crazy.
Yeah, it's incredible.
Yeah, that's why it's a holodeck.
So
This is going to be this platform, this virtual world is both going to be fun to be in as well as useful for creative labs. Yes, sir.
Uri Levad from Machine Learning in Israel. We spoke a lot about the good usage of AI. What about the dangerous or the ethical, the moral question about AI? Elon Musk style, and I would like to know what your stand about this topic.
Anything that's very, very powerful, anything that's incredibly powerful, can be used for good as well as for bad. We know that. Originally, fire was created to keep us warm, keep us safe. Of course, we know chemistry could both help me with my bronchitis as well as be used for chemical weapons, right? And so the internet could be used to educate our children, but it could also contaminate our children with ideas that don't make sense. And so I think all great technologies have tremendous good. That have tremendous good also has the power to be used tremendously poorly. Our strategy is this, and this is something that I think is really very healthy. The first thing is we need to have open dialogue. It's good that you're asking the questions. It's good that people are talking about it. And whether we agree with the dystopian outcome or not, talking about it will help bring awareness that keeps us from that. I think the point is to be wrong. His point is not to be right, but to be wrong. And so to talk about these extremes is fine. I think if it brings alarm, then it's not fine. If it brings alarm, it's not fine. On a practical note, it's probably more likely that AI is used by an evil person to do harm than AI becoming evil to do harm.
The human factor will always be there, you said.
Because there are people already that exist, that are intelligent, that are evil, right? And so they could obviously use the technology in a less than good way for society. I think fake news is really bad for society, frankly. I think misinformation is really, really bad for society. And it's misinformation may very well, depending on how you think about it, the ultimate form of evil. And I happen to take information rather seriously, and I think fake news is not good. And so, in my estimate, we need to get our hands on top of that, get our arms around that, and take it seriously. As far as ourselves is concerned, our strategy is to keep the computing platform open, and that's the reason why you see me supporting every single framework in the world. We're not just going to support our own; we're going to support everybody's. We keep our computing platform in every single cloud. It doesn't matter which cloud. And anybody who would like to bring it into the cloud, my answer is yes. We offer to every single company in the world, including our competitors. If our competitors would like to use our computing platform to develop their artificial networks to come and compete with us, I'm fantastic with that. We got to keep our platform open as much as we can. And the reason for that is because I believe largely that humanity is mostly good. And if we put the technology, this powerful technology, in the hand of the most, it's our best way to keep ourselves out of harm's way. Yes, ma'am?
Hello, I'm working for IPv4 News, it's a French project. And I would like to ask you a question, but the sound is very bad. Can I go closer?
Yeah, sure.
Oh, thank you so much.
Good luck with your cough.
Not, I'm sorry. I just...
Yeah.
Okay. Yeah, next to you.
Now I talk to you like this?
Yes, and if you speak in French.
Yes.
Bonjour.
Or bonjour.
Alors, c'est une chance unique pour moi de
I have
vous
no. What
rencontrer.
are you saying? I thought you were joking. My daughter speaks perfect French. My daughter speaks perfect. She lives in Paris. Hi, Madison. And-
Fast translation.
But
Yeah,
she will hear you.
yes, she's in Paris, and her French is excellent. And so if she were here, she would be my translator. But
I will
since
translate it to you. So,
I get
Jensen
it.
Huang.
Oh.
It's really, je vais le dire d'abord en français. Jensen Huang, c'est une chance unique de vous rencontrer. J'ai un peu l'impression d'être à côté d'une rockstar. Vous avez fondé un empire avec NVIDIA qui est quand même le pionnier dans l'intelligence artificielle. Alors pourquoi tout le monde est fou de l'intelligence artificielle? Why is everyone crazy about AI?
why is everybody crazy about AI? Well, first of all, this is the most significant computer science revolution since the beginning of computer science. Imagine a computer that writes its own software. Imagine a computer that can learn from experience. And it could write software so complicated that no human can read. And so as a result, all of these amazing unsolvable problems, whether it's self-driving cars, or early detection of cancer, or finding the most subtle patterns in a radiologist for medical imaging, or just helping farmers improve the productivity of their crops. These problems, there's so many problems that are so hard to write software programs for. Artificial intelligence can now learn how to work on these problems. And so it allows us to solve problems that were historically unsolvable, and that's what's so exciting.
Thank you very much.
Yes, sir.
Hi, my name is Asaf Roshan. I'm freelance all over the place. My question is about the car manufacturers. What do you think about their future? Will they sell more autonomous cars in the autonomous area? Will they sell more cars? How many of them will survive this era?
Mm-hmm. I actually think that in the near term, call it 10 or 15 years, they're going to end up selling a lot more cars. Two reasons. Every single car on the road today is largely not electric and not autonomous. And I can tell you with complete certainty that autonomous electric vehicles are delightful to enjoy. And so, and I think that everybody else feels the same way, or will feel the same way as soon as they enjoy it. That billion cars on the road, is going to result in the transition to EV and AV. And that's going to be fantastic for the automotive industry. The next, call it 10, 20, 30 years. Then beyond that, we hope that there are fewer cars on the road, right? We hope that there's fewer cars in parking lots and parking structures and your garages sitting around all the time. It's one of the worst utilization of capital that we know. And so if we could go to a ride-hailing or ride-sharing or just more public transportation, shared transportation models, I think society would be better. And so I think in the near term you're going to see some really exciting cars. I cannot wait to buy the Porsche Mission E. Have you seen that thing? That's just amazing. And so I hope I get one of the first ones. But long term, I really do hope that transportation as a service really takes off. Yes, ma'am. Nice to meet you. Yeah, that's a good question. With respect to startups, we've historically not been very proactive in investing in startups. And the reason for that is because we have many ideas ourselves about how to invest and what to go create. And as you know, we have a great reputation for creating the future and investing in creating groundbreaking ideas. And so on balance, I think NVIDIA has already a good use of its capital. And so we historically have been rather passive, if you will, responsive, reactive to investing. Our platform for GPU computing is now flourishing all over the world. And there are all these amazing companies that are using GPUs to solve problems in the marketplace. And so I think our posture will likely change. And the reason for that is because there's so many of these ideas. Some of them are just so good, and it's so helpful to the marketplace that we would love to see them get there faster. And that's really the reason for us investing. If I can help them get achieve their dreams faster, get their products to market faster, and if we could offer assistance in a way that nobody else can, whether it's because of our technology platform, because of our technical capabilities, or is it because of our marketing exposure in the markets that they're targeting. If we could be of special assistance, then we'll do that. And so I encourage startups that feel that that we could be helpful to them to reach out to us. Yeah, there's just so. I mean, this is Startup Nation. Oh my gosh! I understand. At the moment, there are 5,200 startups.
Right.
It's
And
a
one
shocking
more.
number.
And one. Every second is one more.
I know.
And counting.
I know. It's a shocking number, and I think it's fantastic. The entrepreneurial spirit is so great here. It's like in the United States, you have to teach people to not be discouraged by failure. Here, people almost relish it, and in a way, all entrepreneurs do. I relish failure. I just like to fail as soon as possible so I can learn quickly from it. And that culture is really rich here. It's really great. Yes.
You mentioned Mellanox in your keynote. Can you tell us if you have a special cooperation with Mellanox?
Yeah, the question is about Mellanox, and do we have a special cooperation with them? Absolutely. It turns out that one of the most complicated things is when you become super fast in computation, then Moore's law is not the issue. Amdahl's law is the issue. Then the weakest link becomes the problem. And getting the data into the computer for processing by our GPUs is the critical path. And so we have a pipe that we engineered with Mellanox. It's called DMA Direct. It's called GPU Direct. Their data from their NICs go directly into our GPUs. And so GPU Direct is a result of the collaboration in software and architecture between our companies. It's really fantastic.
So GPA Direct or GMA Direct?
GPU Direct. GPU DIRECT.
Couple more, or do you want to?
No, that's okay. That's just what I wanted to do on stage earlier. I get the top entirely like this.
Okay.
Maybe this gentleman back there, because he had a
Okay.
chance.
Yeah.
Excuse me.
You should try Isatis. It's something.
Is that right? Get another recommendation. I took 3 pills this morning, completely on recommendation. And when I walked on stage, I actually kind of felt my head is not in my head. I felt my brain was slightly to the left of my head.
Just take
It was like
Especially if you are in Israel.
everybody cares. You got to take this. This will take care of it.
Tea with honey.
You got to take this. Yeah.
Tea with honey.
Tea with honey. Okay, all right.
The Jewish medicine is chicken soup.
Chicken soup. All right. We're tea and honey.
A lot of press. You spoke a lot about robotaxis and also about autonomous car. In what areas of the world will we see it first? When will we see it first, do you think? And how do you look at the responsibility in case of accident? Who is responsible and things like this?
First of all, these robot taxis are likely to operate relatively soon because they're what we call geofenced. It will only operate in a location where it has complete confidence in the location and the map, and everything has been digitally mapped. We call it an HD map. And so number one, it would only operate in specific areas where the car has tremendous amount of confidence and it has a lot of miles of practice. So that's number one.
Will it be closed area? Something like, for example, this area?
No, it'd be much more. It would be much larger than that. It could be like San Francisco. It could be like New York City. It could just Phoenix, Arizona. It could be large areas that has been fully mapped. And in those conditions, remember that a robot taxi has lots of sensors and it's recording everything. And so if it were to get into an accident, first of all, it has a lot of data to be able to decide whose fault it was. But if it turns out to be the car's fault, the manufacturers or the service providers liable. And so just as you would expect.
But in terms of the world, where do you think we'll see it first, the robotaxi? In terms of all the world, will it be first on the States? Will it be first in China? In Europe? And also about the autonomous car. In what part of the world would we see it first?
Yeah, it's hard to say. For robot taxis, the benefit of robot taxi is the greatest where you already have a lot of taxis, right? And so if a particular urban environment already has a lot of taxis, it's because the culture, obviously, the conditions of that city, obviously would love to have taxi services. And so you could imagine San Francisco and New York and others. Wherever these taxi services are successful, I think you could probably imagine those being the early markets.
So Uber drivers will be unemployed first.
No. It turns out that the world has a great shortage of drivers at the moment.
Do lane markings on the roads play a part in the platform of the autonomous car? In other words, the markings when I drive in lanes. Do they make any difference in terms of computing or programming the car to drive right or wrong?
Yeah. So having lanes visible makes a very big difference. But even if you don't have lanes visible, if it's digital lanes that the car knows that it can drive through, it's a virtual lane. And so the car has a database that the car has a database called an HD map where it knows what these virtual lanes are.
Just so you know, you're running out of time.
Okay, what do you guys?
You want maybe one more question from someone who's not had a chance?
Something,
Maybe this gentleman?
something personal.
Can you talk about how you see AI involved in education?
AI is already being used in education. You know we don't have enough teachers, and teachers don't have enough time. And the benefit of AI, in fact, I forget which university was it. I think it might have been MIT, but actually a digital teacher was answering questions for their students, and it was revealed at the end of the session, at the end of the quarter, that it was actually AI.
It was part of the assistant.
It was an assistant professor. And so I think AI could play a very significant role in expanding the good quality education to a large number of people. It'll never replace the gifted professors, or it'll never replace the professors that are doing groundbreaking research, or the passion of someone who just loves teaching. Because the best teachers are the ones that has great IQ but also great EQ, and they just have a passion for teaching. They love the students, and it's I think for some time that's going to be missing. But it raises the bar of the common denominator of education, and I think that's fantastic. I'll just take one more question.
Elon Musk said something personal. Elon Musk said last week that he has a Ford Model T and a Jaguar E-Type 1967. Which cars do you have in your garage? Collectible cars?
I don't have any collectible cars.
So you're not interested in cars yet?
I like good cars, and
fast cars.
But I live a really simple life.
Okay.
Yeah, I don't have anything I don't need.
So what is your daily car?
I drive a
Toyota.
Tesla.
Please don't
P.
say a Camry.
I'm sorry.
Please don't say a Camry.
Oh, you said Tesla.
No, it's a Tesla.
It's an electric Camry.
Okay.
Can you elaborate on your relations with Tesla? What? In general, Tesla is a company.
Yeah.
Good. I mean, if Elon is help, could use help in anything, we're always there for him. And then they use our technology for training and deep learning, and they use our technology in their cars. It's.
So their autonomous car will be based on your technology?
Their current P100s and Model X and Model 3 all uses NVIDIA's technology.
Yeah, but there were reports that they are going to ditch the NVIDIA chips, and they are developing their own chips based on ARM technology.
It's possible. It's possible. Until then, we'll support them. And if a customer doesn't need you, it's okay, right? There's somebody who needs you. And so I think we're not in the business of selling matchsticks. We're in the business of helping people build cars. And if we can be helpful to them or anybody else, I'm always there for them.
We should wrap up there, right?
How important is Tesla to the auto industry to change?
Sir, I think we've got to give
this young
him
man
a
one
question,
last
and then that's it.
Thank you. With NVIDIA's Tesla processor, how is this affecting AMD's Vega processor?
AMD's Vega Tesla and Vega serve completely different markets. Tesla is designed for high-performance computing. The testing of it, the technology inside for reliability, the software stack on top of it to accelerate all the applications for high-performance computing, all the deep learning frameworks that we support, all the tools that are available. The 600,000 developers in the world that know how to program Tesla makes the Tesla platform viable. And so Tesla is not a graphics chip per se. Tesla is really a GPU computing platform, and it's also the most successful, most pervasive high-performance computing platform in the world. It's more popular than any HPC architecture the world's ever seen, and so So whether you're doing weather science or material science or AI science, it doesn't matter. Tesla is the perfect processor for you. So I think it's just a very, very different world.
Okay, let's let the man keep the rest of his voice.
Yeah.
Thank you very much.
You guys.